All right. Well, I hope that everybody had a good weekend. By tomorrow, we're going to finish up the law of sines and law of cosines. We'll finish the ambiguous case today, and then tomorrow I'm going to go ahead and take time to do a few things. I want to go ahead and show you how to find the area of an oblique triangle using some different formulas. And then I also want to go ahead and derive the law of cosines. I've been talking about that, and I did this morning write one up, and I went ahead and scanned it to the website. So if you want to go ahead and take a look at that ahead of time, it's already on there. But Wednesday, I'm not going to be here. I will be on campus. I just won't be in the classroom because I'll be doing the IB CAS interviews that day for the seniors. I think the juniors are on Thursday. Is that correct? Anybody IB in here? No? Jordan, you're IB, right? Okay. Is that right? Think it is? Okay, well, we'll see. So with the substitute, I'm going to go ahead and leave the assignment for the law of sines and cosines. If you want to get a preview of that, I mean, it's already on the website, but I will go ahead and have a hard copy for you this time. You'll have the entire period to work on it, help each other out. We'll turn that in on Thursday. We'll end the week on Friday with a quiz over that material. And I'm hoping that tomorrow we should be able to go ahead and start the next section, at least get some of the notes copied so that Thursday we can just get right into the material, graphing sine and cosine. All right, that's what's happening this week. We are now in the third 6 weeks. Any questions? Okay. How many weeks are we away from our first Thanksgiving break? 3. Including this week, only 3. So 2 weeks from Friday. It's going to be happening quick. We have 3 weeks until Thanksgiving. You get the full week off. We come back, 3 more weeks, and then we're off for Christmas. So the rest of this semester is going to be going really fast. Okay, well, let's go ahead and get going. This is what we were talking about on Friday, the ambiguous case, when you were provided 2 sides and a non-included angle, so side-side angle. This table right here was going to help you figure out exactly how many triangles, if any, would support the given measurements that you had. So the top row, if it was acute, you have one of these 4 possibilities. If it's 90 degrees or obtuse, you only had these 2 possibilities. And one of the things you were always provided was a pair. The angle measure you're given, you're always going to have a side length directly across from it. So let's just get right to a problem and see what you think. Oh, did somebody not? Oh, did not hear me. Hello. Okay. Did you have a pass, or were you coming from that same class? Just late. Okay. Just late in general. Okay. What class was it that the rest of the folks are coming from? Capstone. Okay. Maybe Capstone. Okay. All right. So here is our first example for today. It says find all solutions for the given triangle if possible. If no solution exists, write no solution. Round the side lengths to the nearest whole number and angle measures to the nearest 10. So here are my measurements. Angle A is 45 degrees, side A is 18, and side C is 24. So you'll notice on this one, they're already switching up the variables. So I want to emphasize the variables themselves don't matter, especially if you're using this table here, because you'll notice it always compares A to B. So in this instance, if you want to use the table, we'll just go ahead and replace every B with C. Okay, just go ahead and fit our information. So that does not matter. All right, so if I come back over here, first thing I want to go ahead and point out in this diagram that we do have a altitude already drawn here for the height. It's just that this resource kind of put the 18 in the wrong spot. The 18 is actually that length right there. Okay, you remember we talked the other day, and I actually showed you the visual, that this side, okay, side A, kind of swung over like a pendulum and created a second smaller triangle. Okay, well, what we want to go ahead and do is just figure out, first off, can a triangle be written or drawn using these measurements? And if so, is it possible that a second triangle could also have the same measurements? All right, well, first off, what do you notice? Do we have obtuse or an acute angle? We have an acute. All right, so immediately I already know that we got to be looking at the top row of my table. The bottom is already excluded. Now, how does A compare to C? Is A greater than or less than side C? Yeah, 18 is less than 24. All right, so I'm going to take this information back to my table. All right, so we already know the 2 possibilities in the second row are out. So I'm looking at the conditions here. Now, remember, we're just replacing B with C, so A is less than C. That's a possibility. A is less than C, another possibility. A is less than C, yet again, another possibility. A is greater than or equal to C, I know it can't be that one. All right, so it has to be one of these three outcomes. And you'll notice, what's the other bit of information that I need? I need to know that height. Okay, so I'm going to come on over here. So this altitude, just look at that as a right triangle. And if it helps, go ahead and call that point D. So we could say triangle ABD. But if you go ahead and be consistent with your diagrams, even though they're not going to be entirely correct a lot of the time, it's going to make it a lot easier, and you'll always be able to use the same trig function. Like in this case, what would the height and 24 represent to 45 degrees? Yeah, sine, because they're the opposite and the hypotenuse, right? So let me go ahead and unhighlight that right there. Okay, so I'm going to say sine of 45 degrees equals the opposite height over the hypotenuse, 24. And how do we solve an equation like that? There you go. You just multiply through by that denominator. Remember, cosecant would have also worked on this, but it would have put h, down in the denominator. So let's see here. Let me go ahead and get rid of that. Oh, it is not letting me do that right now. So let me try this one very quickly. Go back over here. There we go. Now let's try it. Document B. Okay. So what do we have here? I forgot the numbers. 24 sine of 45. So 24 times the sine of 45. So I'm getting the height to be 16.97. So the instructions did say to round the side lengths to the nearest whole number. So I would definitely say 17. I mean, that's already pretty high in decimal. So the height is about 17 units. So how does side A compare to the height? We have 18 and 17. So A is greater than, right? So now I'm going back to my table with this additional information. A is less than the height. That's not it. A equals the height. It got close. A is greater than. So this is our first example where we have what? We have two triangles. That's exactly right. Okay, so let's talk about these two triangles that we're going to have. So come back over here. Let me erase this. Now I'm going to go ahead and highlight these. Again, you don't have to always draw the triangles in this fashion. I just find it's easier and a lot faster to go ahead and be consistent. So first we're looking at triangle ABC, the one that I've highlighted here in green. Okay, so let's say this guy right here. So A, C, and B. All right. Now, remember the other day we had this side A, and I talked about it a few moments ago. This side right here that's 18 was going to swing over like a pendulum and create a smaller obtuse triangle. So I'm referring to this second triangle that we're going to find right here. Okay, now I still have angle A, but these original angles B and C, they're not going to be the same measurement that we have in this new triangle. So that's why here it calls this C prime. So we'll go ahead and call this top one B prime. Okay. Is everybody okay? Any questions? Well, let's go ahead and fill in my information. We know that angle A was 45 degrees. So 45 degrees. 45 degrees. We know the side length across from it was 18. So here's 18. This side length is 18. And side C was going to be 24. So here's 24. And here's 24. So there's your side angle scenario. Okay. Well, here's the nice thing. Once you get to this point right here, it's just like everything we've been doing last week. All I want to do is find the missing side lengths and the missing angles. Okay, so let's start with triangle ABC, the green one. Where should I start, and what can I use?
45 and 18.
Okay, what about 45 and 18? That creates a what? That's a pair.
So you can use 24.
There you go. So I'm going to have to find angle C first because the only other bit of information I have is 24. Okay, so law of sines. Sine of 45 degrees over 18 equals sine of angle C over 24. Would everybody agree? Okay. Now, one thing I've been encouraging you to do is go immediately to the expression that you would just type in the calculator. Would anybody like me to show the cross multiplication, division, anything? In fact, there's one other step here. We're looking for a side length or an angle measure. An angle measure. So what am I going to have to do to sine? I've got to take the inverse trig function. Okay. So if I were to cross multiply, I'm going to take sine inverse of some ratio in order to get C. What would go up top?
24.
Okay, so 24 sine of 45. And then below that would be the 18. Is everybody okay? All right. Well, let's see what angle measure I'm going to get for C. 24 sine of 45. Here we go. So 24 sine, put that 2 in there. 24 sine of 45 divided by 18. Somebody help me out. What should I get when I push enter? What is the measure of angle C? 70.5? Okay, that's exactly right. So now I'm going to go ahead and say this is 70.5 degrees. I don't have to use either law to figure out angle B. I can just what? Just subtract from 180. We already have two of the three angles. So I'm going to go ahead and take the 180 minus the 45 we already had, minus the 70.5 that we just found. So let's say 64.5. And see, right there, with one calculation, we're almost already done with the first triangle. Is anybody not sure with anything I found? Any questions? Okay, what's left here? Okay, so I got to find side B, right? Okay. Now here's the thing. You have enough. We could use the law of cosines. We can continue to use the law of sines. I'm just going to go ahead and use the law of sines, but if you want to, I'd encourage you to use law of cosines. It doesn't matter. So I'm once again going to go ahead and say sine of 45 degrees over 18. But what's the ratio if I'm looking for side B? Okay, so sine of 64.5 over that side B I'm looking for. Okay. So what would B equal? 18 sine 64.5 divided by sine 45 degrees. There we go. Now, we're not looking for an angle measure here, so we are not taking a sine inverse. We're simply finding a side length. So let's see. 18 sine of 64.5. 18 sine 64.5 divided by sine 45. Okay, what should I get here?
23.
Okay. So 22.97, again, another very high decimal. So I'm okay. Saying 23, just rounding it to the nearest whole number. There we go. Exactly what we've been doing this past week. Okay, just finding the missing angles and the missing side lengths. Any questions? Okay. But now I know a second triangle, an obtuse triangle, exists with that angle and two side lengths. So now I just need to go over there and finish finding him. Now here's one thing that's really of use to you. Once you find this first angle right here in the original triangle, you already have this C prime angle right here. Let me show you why. Remember, this obtuse is inside of the other one, right? Let me go ahead and extend this and go back to C. Remember, we found him to be 70.5 degrees. This was 18. Well, look at triangle B prime, C prime, C. What kind of triangle is that? What do we call it when we have two side lengths that are congruent? It's isosceles. Because these two sides are congruent, I know that those base angles have to be congruent. So I know this is 70.5 degrees as well. That's a 7. Well, how does that help me find angle C prime?
Drop 180.
Yeah, there you go. What's the measure of a straight angle? 180 degrees. So all I need to do is just take 180 minus the 70.5 that we already found. Oh, it's 18, sorry. 180 minus the 70.5. Let's get a positive angle here. 109.5. So this missing angle is 109.5 degrees. And that also helps me find what?
The other angle.
Yeah, the other angle. Okay. So I already know I have 45. So 180, make sure I type 180 this time, minus 45, minus the 109.5 that we just found. So I know the measure of B prime should be 25.5. So this angle right here, 25.5 degrees. So this angle right here, the bottom right, that's what you're going to most likely find first. As soon as you have it, it automatically allows you to find the other angles in the second triangle very easily, because it's going to be the supplement of that obtuse angle. Remember, what's that word supplement mean? The two angles add to what? 180. Okay. Is there anything that I'm missing that I didn't find? Bless you. There's one thing I still need. There you go. I need the base of this obtuse triangle over here, what we're going to call B prime. Okay. So we can just quickly do another law of sines. So let's say sine of 45 degrees over 18 once again equals. Now, if I want the base of this triangle right here, I got to take sine of what? 25.5. There we go. Over that B prime. Okay. So again, cross multiply. B prime is equal to, what ratio would I have here? 18 sine of 25.5 divided by sine of 45 degrees. All right, somebody help me out here. What am I going to get from that expression if we round it to the nearest whole number? 11, because I think it was like 10.9 something, right? There you go. And that's it. So if from the table it does turn out there are two triangles that'll fit those measurements, it's basically just like solving two triangles at the same time. Okay. That's all there is to it. Is anybody confused or lost by what it did? Okay. All right. Well, let's try another one of those. Find all solutions for the given triangle if possible. If no solution exists, write no solution. Side lengths to the nearest whole number, angle measures to the nearest tenth. So it's the exact same set of instructions, but now I have angle A is 24 degrees, side A is 13, and side B, so we're back to B, is 15. Okay, now here's the thing. Would you like to try this on your own, or would you like to go ahead and try it together? So this could be any of the cases. On Friday, we saw no solution, we saw the one solution, and we just saw our first two solution. This could be any of those three. What would you guys like to do? Together or individual?
We just have somebody go up and do it.
Oh, you want somebody to come up and do it? Oh, I like that idea. Okay, so how about this? How about I go ahead and give you 5 minutes? That should be enough time to go ahead and work through the problem, hopefully to at least determine if there's one, two, or no triangles. And then we'll go ahead and get somebody up here to kind of help me out. Okay, so I'm going to go ahead and put another 5 minutes on the clock. Where did I do mine? Ah, here it is. And remember, this is a perfect opportunity. You know, compare your answers with your villain buddies. You know, see if they're getting the same thing. Are they using different strategies? Okay, what's going on? Jordan, you have a question? You have villain buddies now. That's good. Yeah. In fact, who are your villain buddies? You're the cat women. So you can lean over to your partners and say, "Hey, help me out. Help me out." Really? No? Come on. You know, I got to admit, I'm feline pretty good about that joke. Does anybody need help? Is anybody stuck? Okay, so I've got 2 minutes. Can anybody at least tell me how many triangles, if any, we should have? This one will have 2. Okay, we'll have 2 triangles. All right. So let me go ahead and do that while you guys are finishing up. So we're definitely going to have this larger triangle. Now they're giving me sides A and B, so I'm going to put A here. All right, so that means this is 24 degrees. The side opposite that is 13. And then because they're giving me side B, which is 15, this right here has to be angle B. And this would be angle C. Okay, just because of the information I was provided. All right. So I believe, didn't you get the height to be around 6? Okay, there you go. Which side A is greater than that, and side A is less than B, so it's the same set of circumstances from the previous problem. So I'm going to have this triangle right here. I'll just go ahead and copy it again. So here's A, 24 degrees, there's 13, there's 15, there's C, there's B. And then we're going to have this second triangle. Okay, right here. And we'll go ahead and call this A prime. Okay, so A is still 24 degrees. We got B prime here. This is now C prime. This is 13, and this is 15. So we have 2 different triangles, each with 2 side lengths that are the same and 1 angle measure that's the same. Side angle. Okay, and that's 5 minutes. Is there anybody who'd like to come on up and help me out with this? We don't even have to do the entire thing. Maybe we can even get several people up here. For triangle ABC, again, I would probably start where? I'd use law of sines and first find angle B. Okay. And once you have angle B, that automatically allows you to find what other 2 items very quickly. Angle, well, C prime. Okay. What would, yeah, C and then C prime and then B prime. Yes. So 3 items, I'm sorry. All right. So who wants to come on up and show me? And let's get somebody who hasn't been up here yet. Because I think we're kind of getting into a routine where the same people here keep coming up again and again. So who has never been up to the board? Okay, so this is definitely where nobody's making eye contact. Okay. All right, should I just use a random number generator even though we know it's not 100%? Okay. So in this classroom, that goes to, presumptively, you are 12, correct? Then it should go 18, 24. So it should go through seat number 28, which is Rio. Okay, so let me go here, A, menu, probability, random, integer. Okay, so I want one number. I'll even go ahead and put 30 just to make sure. Okay. 29. Is that Galen? 26, 27, 28, 29. So that would be behind Rio. Okay. 28. All right, Rio. Okay. Now, I'll tell you what, you don't have to do the same thing. You don't have to do the entire problem. Why don't you just help us find angle B? So sine of 24 over 13. Perfect. No, you're right. Okay. Sine of angle B over 15. Perfect. So 13 sine of B. Actually, wasn't it like 27 point, a very high decimal? In fact, it was such a high decimal, I probably wouldn't even round this to the nearest tenth. I would just go ahead and say 28. Isn't that what you got? Okay. Okay. All right. Okay, thank you. All right, there we go. So we got this angle right here to be 28 degrees. Okay. So somebody help me out now. This will immediately help me to find C. So I'm looking for 180 minus 24 minus 28. It is supposed to be obtuse. Now remember, your diagram may not always fit, but that's okay. It's the information that has to be accurate. Okay. So 128 degrees. Would you guys agree? Now, if we know angle B, this provides me what? There you go. Because this right here, if I were to extend it with the isosceles triangle, and this was still 13, and we knew that the base angles were congruent, 28. I'm trying to do this with a mouse, which is why it looks horrible. Then this one right here should be what? 152 degrees. 180 minus 28. So now for this C prime angle right here, 180 minus 24 minus 52, that's 4 degrees. Okay, how's everybody doing so far? Is everybody getting the right values? Nice, and there's only one item left. What is it? C prime. Okay, the base of that obtuse triangle, of the second obtuse triangle, I will say. Okay, so do I have a volunteer to come on up here, or do I need a random number generator to help me out with the last one? So many volunteers. What will I do? Okay, let me turn this calculator. Natalia, you want to do it? Are you sure? You do come up a lot. Well, I think secretly they want to. It just kind of encourages them when they get chosen. That's correct, don't you think? Sure. Connor agrees. Okay. All right, but Natalia, we're almost done, so I'll let you come on up. Okay. All right. Cool.
So we're finding this right now.
So now we're just finding C prime, the base of this triangle right here. Yes. Oh, we didn't even find the other base, did we?
I did.
I completely forgot about that. Yeah, go ahead. I went ahead and skipped right over that and started looking at the right second triangle. Sorry about that. So sine of 24 over 13 equals... Okay, sine of 128 over side C. Okay. So 13 sine of 128. Oh. Over sine 24 degrees. Okay. Nobody has that? There we go. It is 25 units. Okay. Now, since you worked that one out, if you already have the base of the other one, I'll just go ahead and take it if you do. Does anybody have that length? It is 2. That's what we should be getting. Perfect. That's it. So it's just like solving two triangles at the same time. Does anybody want me to elaborate on how we got that 2?
What can you use law of sines if you solve cosines?
You could if you wanted to. Like in order to find that 25 that we just did. Now that we have angle C and we already had the other two side lengths.
Don't you have to use, I thought you couldn't use law of sines if it's obtuse.
Here's the thing. Now, he brought up a good point from Friday. We couldn't use law of sines if it was obtuse. We didn't use sine inverse to find that angle. Yeah. See, sine inverse is incapable of giving an obtuse angle, but we can calculate sine of an obtuse angle. Okay, it's just that sine inverse will not produce an obtuse angle. Okay, so that's a good question. That's a good point right there. Okay, so law of sines does work out in that case. All right. Any questions? Is there anybody not understanding where I got any of my values from? Anything? Okay. Well, I know we have a little bit of time left, but with the announcements, this is as far as first period got, so we'll go ahead and call it for today. Tomorrow we'll have another Happy Minutes. We'll have our first focus activity of the current grading period. We'll finish up this lesson. I'm sorry? The first quiz is on Friday over this material. Okay? Sure. Yeah, that's fine. So you're on Thursday and Friday? That's okay, I'm on Wednesday.
When do we have Friday off?
I think the next Friday you get off, besides Thanksgiving vacation, it's like the 6th, December 6th. Yeah.
Really?
Mm-hmm. That's when we have another content focus session. Okay. Unfortunately, this is a full week. I wish Friday was a day off. That would be nice. Okay. Yes. No. If anybody's absent, I just exempt them. And that one was just practice anyway. Yeah, it wasn't for a grade.